Criteria for flood proof and sea level rise consideration. So this project, this original project, was a great sort of example and very exemplary of the things that CBF wants to do and things are right in the world. This building is obviously super elevated because in 200 years, Chris, is that sort of that was the projection?
Yep.
Where water is going to be, and they wanted this building to still be viable at that time. We may come by canoe, but that's where they wanted to be. So obviously the city of Virginia Beach's flood criteria 5 years ago were quite advanced. They upped their freeboard game, so it's grown, I think, a net of 3 feet from where it was previously. So our criteria on the addition were greater than they were here, but in a lot of ways we still needed to meet some of the goals the client had about elevating the building way over and all of that. So the building is set at the same level as this building is, but then we have obviously mechanical systems and electrical systems that are down low being fed from the utilities. Those only meet the current criteria for mechanical electrical systems. One of the things that I had never done before, and I've dealt with flood proofing and that kind of stuff a lot, one thing I had never done before was try to find common sense levels for certain elements. So the basement, the sort of mechanical room down low, the flood proofing criteria will tell you where you have to protect to, which is 6 feet above grade. But that's the 100-year storm. And we all know, and certainly CBF believes, that you're seeing more major storms more frequently. So when we were designing the door for that, we wanted to set the sill at a place that made sense for a more common storm. And I had to dig through. FEMA actually publishes, if I remember correctly, 10, 20, 50, and 100-year storm numbers. So I went back and grabbed the 10-year storm number, and that's what we used to sort of set the sill of the door. So when you get over there, you'll see the sill of the door is 18 inches more or less above adjacent grade. And that was, we have a flood-proof door. It's crazy expensive, it's crazy heavy, it's way high-tech, but trying to provide protection sort of with the building without any of these systems having to work. So if they, because we're doing the flood-proofing with the door that opens and closes, it's subject to gaskets and things that are going to get moved and are going to degrade over time, and it sort of asks a lot of the owner to always keep up with every little piece of rubber and such that are in that door to make sure that it's always at peak sort of operating performance for every storm. So we tried again to sort of take a common sense approach. What are we going to see on a fairly regular basis, and how do we set heights and things to accommodate that? It just so happened that right before we started construction, we had a pretty plain Jane nor'easter, and Chris sent us a picture of him standing in knee-deep water. He sort of drove himself out here to go stand where the building was. We got a picture of like water just below kneecaps, sort of being down. It was like, here's what we've got today on a day that nobody else in the region is seeing any significant flooding. This is what we get here. So, you know, I mean, your clients many have special criteria. Certainly they do, and I, sort of applaud their forward thinking on that. Discuss system design for net zero water consumption, independent sanitary design. Am I going to hand this off now? Yeah. Do you want to talk about your system? Is it mostly your system?
Yeah, well, I could talk about the rainwater and everything with that, the sanitary and the dry compost. Talk about the reused water. So we're designed and implemented a system that's almost identical to the main building. All of the water that interacts in the building comes from rainwater. It has the same general systems with a vortex filter. The same thing out in the front of the building. We have another one that we're going to install. And then the water will then be stored in 3 large cisterns, which effectively triples the entire water storage volume for the entire center here as well as the classroom. And then that water will be pumped over to the treatment system that's already in place and already in use. And then of course, and then get pumped back and then used in domestic similar to what we have here, just there was quite a bit of, how do we collect it there, send it here, and then send it back. And beneath our feet there's a trench right next to the rooms. The pipes come out with the cistern room, I think right about here. And they come down and sneak out the building and come up over there. And all the pipes are in the same trench to make it simple and easy to work with. It's somewhat complicated, but also pretty simple. If you kind of break it down and see how it works. We wanted to make it easy to see the
In a lot of ways, we got to piggyback our systems off of their systems. Their systems were over-designed, more or less. The water quality system had lots of throughput capability, but not enough storage capability. So you guys never ran out of water, but you got close?
Yeah, so the system was originally designed to hold about a 30-day drought, which about 7 years ago when the building was designed, that's what was forecasted. And then over the 5 years before we started designing this, we started to see that we would get a lot of rain in the fall, and we would have longer periods of drought. So they estimated the building would use like 145 gallons of water a day. In reality, we used between 30 and 80, so we allowed that drought period to go much longer. But there was 2 years in a row that we would get all the rain at the end of September, early October, and we wouldn't see rain enough to fill the tanks until right before Christmas. And so it got really close. We do have domestic water here for life safety in the event that we have to switch over, but the goal was to not. So we took this opportunity to really kind of tell the story that we're going to, instead of pushing the water in rain gardens, let's capture it here on site and supply this building. And this building really is its own municipality now to the classroom, which is really nice. So it's very interesting that we're storing, like Evan said, triple the capacity over in the other building as raw water, and then it gets treated and then stored as potable water in both buildings at a greatly reduced volume relative to what we're storing. It's just kind of an interesting system, and eventually, between the building being where it was vertically, we had a lot of wrestling to do with the damn cistern sizes. And we only redid it like 2 or 3 times. And they started installing them, so we're not going to do it more. Kevin, did you have a question? I seem to recall in the original building that the city wasn't completely sold on the water and was making you bring full domestic from their systems. Did they have that same requirement here, or were they convinced that
No, unfortunately, we have to be relevant to the monitoring of the system and making sure it all still works and all the water is on thing for us. We had the system building open 4 or 5 years worth of data that basically said it works. The city connection is there in case of emergency, but it's not really necessary. And we worked back and forth with EDH, they were on board. Everyone wants the project to work. They kind of want it.
That was one of the biggest meetings I've ever been to. We went to go talk to the health department, and they had been talking basically constantly for 5 years. So it was a meeting where we all sat down, they shot the shit, and it was like, is it going to be like the other thing? Yes, it is. Done.
Yeah.
And it was so, for a system that caused them such heartache the first go around, it was, they had all done the legwork. It was so painless for us.
Yeah, that was like 2 years of those meetings to get it to do it for this building, even to the point that like we had people walking the door for grand opening, and the guy was like, all right, I'll sign off on it. I mean, it was that close to it. So we, with the help of MSA, it was really helped us run it super efficiently. It was great to have them on board and see that.
Has any other building used your data to try to get the same system through
Yeah.
the city?
So we were the first in the continental United States to really get it on this scale. And then once we did it, I think there's 6 buildings now in the United States that are doing it, and they've really kind of used the model. They've all done it a little bit differently, and the thing that we're really proud of is we're the ones that have been doing it consistently the same way without having to change stuff throughout the entire 5 years operating. And most importantly, California just jumped on board and permitted it a year ago to be able to do this, and they're building a building just like this in Santa Monica.
Oh, cool.
So the other half of this learning objective is the sanitary, independent sanitary, and Chris knows way more about that than I do. A composting toilet, which looks really weird the first time you actually use the restroom. It like they've been more or less maintaining it themselves with their own over there.
We've been using composting toilets since the 70s in education facilities around the way. We built the model center. Our building in Annapolis, it was the first commercial structure we put them in. So that building's 20 years old now, and they've been working well. It takes 2 to 3 years for the system to establish itself. Once it does, you get about 1 wheelbarrow mulch per bin per year you can put on your native landscaping. Because we're in the floodplain, we can't actually put it on our landscaping. We take it off-site, but at the end of the day, it's very efficient. And then we take the black water off of that, store it on site, and then it's pumped out quarterly and goes to HRSD to be processed.
And that's another system that no one was really comfortable with here locally, and they made them, and then us, put in all sort of safety valve systems for, we know this is going to fail, so when it does, your connection to regular sanitary is kind of ready to go.
Yes.
But they haven't had to use it, and we don't think we'll have to use it. It'll all work just like it has been. Elizabeth brought up the indoor-outdoor. So Chris and the CBF have in this room here, which is more or less similar to the room we're creating over there, a big folding wall to try and get in and out. Very central to sort of the programming and design of this building. But we are not San Diego. This is not a great environment to be opening the windows and opening like 75% of your wall to the outside on any given day. So one of the things that we did without, well, sort of, I guess from a liability perspective, that's such a crappy way to look at it. There's no drywall used in the building. We assumed that the inside of the building would see 100% humidity all the time. It was always outside. We did not, from mechanical systems, assume that it was a naturally ventilated building because that is a huge headache from a mechanical system design perspective to try and do. So it's not technically designed like that, but it will operate like that. It's got enough sensors and things that it will be smart about being open to the outdoors and not being very wasteful with mechanical system energy. So that went to every component of the building is more or less tolerant of being very, very wet and drying out very, very slowly. So the walls are all plywood. All of our ceiling tile is all Tectum, which you can technically put outside. Every component, the casework is all made out of marine grade plywood. I'm like, it's all ready for the apocalypse to happen and electricity to go away and the building to just operate like it did 200 years ago. Then the last one is where I wanted to land, which was, I called it Keep It Simple Stupid, which we never referenced it that way during the design process, but Chris was pushing really hard to make the building be able to speak to your typical homeowner. So they have tours here, and the goal is that people leave here changing the way they live their lives, and we can all save the planet one person at a time. But what Chris has said all along is that people more or less get overwhelmed with this building. It's crazy high tech in every possible way. So people leave going, that's awesome, but I can't afford $1,000 square foot house. I can't. So I'm just not going to. So we really tried to design building envelopes and things like that over there in a reasonable way that was accessible to your average homeowner. So we don't have continuous insulation over there. We have a pretty generic 2x8 wall with that insulation. There's nothing exotic about that. The skin is on a rain screen, but again, not super exotic there. We have a spray applied barrier, which is a little bit something nicer than you would have on a typical house, but high performance design really is about controlling leakage and all of that. We use a Pella window. Who doesn't know who Pella Windows is? I mean, we used high performance versions of stuff that everybody knows. And again, you don't have to go to the triple pane, Krypton filled, all of the craziness that we went to. But if you do, we only upgraded windows and sort of vapor barrier and are getting a building that is really quite efficient. It's not quite as efficient as this building, but doesn't go to quite the lengths that this building does. So I think I've more or less covered it. I'm happy to field any questions or do so while we walk. Shall we?
Can I just say one more thing, Michael?
Yes.
The whole purpose of the building is a classroom that will be operated by Virginia Beach City Public Schools, and it's their new environmental science program. So Time Off and Moss has designed a building for 100 students that will use it, 4 classes a day ultimately. They will be learning about sustainability and careers moving into the future. So that is really the whole premise behind this entire project. And so it was really, these students will be taking this project, kind of taking it apart, and then kind of going out to the world from here and becoming the next architects, engineers, leaders, if you will. So that was really important to us to make that relatable as well.
Yeah, and I think sort of the final aesthetic might be a little rough around the edges, but the building is seen as like a field office that you might launch your investigations into this beautiful site from. It's not intended to be as refined as this building is. If that makes any sense. Okay,
But
it's pretty awesome. Or are you guys going to join me?
All right.
Chris only said that in every one of our design meetings for months. We're talking about like, how do we make it relatable to your average person? So one thing that they didn't get to do that we got to do was cast in place exposed concrete, which is totally awesome. First time I've done it, and we learned a lot from it. I think everybody learned a lot from it. I almost made this a learning objective because it was so not easy. And if we had had more time and more money and lots of other things, we would have sample paneled this thing to death and really nailed it, but we had to kind of do it on the fly. Again, it's not that exotic, it's not that crazy, but apparently, for any of you architects out there, board-formed concrete does not mean what you think it means to all the contractors. They gave us some they thought that it means plywood formed, and that's not at all what it means. So we had a little bit of an argument there. Ultimately, we got there. This was boards that were installed on the inside of regular plywood board formed stuff. So we were supposed to be 12 inches. There's our sill that we picked up, quite a bit. No one's given us any grief yet about stairs up to it. CBF will probably build a set of wood stairs that will be there when needed and not when not. That we had to measure to the first joint in the clamshell of the composting tank. So that height isn't the flood height. That height plus the bottom half of the plastic clamshell equals the water height that we have to keep the water clean. So the concern obviously is flood water comes through, collects all of the cool stuff that Chris is storing inside of his composting toilet tank, and then spreads it through everyone else and makes them all deathly ill. So we were really counting at some point like quarter inches and half inches, and talking to the manufacturer like, so when you say your seam is here, you mean it's really here, right? Like not somewhere else. This whole basement is just to support that thing. There's a sump, there's a heater, there's a couple of other pieces in here, more or less all to support that thing. I think Evan has one piece of equipment hanging in the corner.
Yeah, that lower wall's got equipment for the cistern, right?
But it's only here because this room is here.
Yeah.
Otherwise we would have put it somewhere else.
Yeah, it's weird basement to put it.
So there's the first cistern tank, and as much as it looks like there's a ton of clearance in there now, that's another one we were playing inches games at some point about how big the cistern is, how does it literally get in place and get out. Your cistern in your existing building is inside the building, and if you have to replace it, there is a piece of CMU wall that gets removed so you can put the thing back in. And to me, that made as much sense as putting a screen door on a submarine. Like, we're going to build this awesome flood-proof bathtub, and then we're going to put CMU in it, which is as porous as anything could possibly be. And then we're going to hope that some fancy paint sort of saves the day. So, and it wouldn't have mattered anyway because we needed so much cistern storage capacity that to build that room that size would have been just absurd. But it is the reason why, like, the sill is high and the door is kind of what it is. It's about the minimum size it can be to accept the Livus tank. Anyway, it's been really fun dealing with all these exotic systems. Luckily, Evan knows. Chris knows better than anybody else.
Well, I think it was a lesson that we learned at this building when you're pushing forward to make it all happen. It was like, where do you place it? Let's put it in there. But then we were able to design this building, understanding how it's actually operated, right? So how these are placed and made to get into the top of them, right? Those are things we didn't think about. We were like, let's just make sure we have enough space for them. But I know that the design team was great. They allowed us to think through it more probably than they needed us to, but we did so we can understand to make sure that this operates as efficiently as possible without everybody is gone.
Yeah, and I think that's where we landed. We just framed it there, and then when we're all done, we're going to move it back and attach it to those new foundations, and you just take the stair. Like, as an architect, you draw it. You're like, okay, we're going to take this stair, and we're just going to move it over here. But this time, like, we physically did it. Not we, somebody, but right. They physically just picked it up, sat it over there for a few months, and they're going to move it right back. So that's really cool. This one's a lot bigger. We thought for a minute about reburying these things, but we weren't sure what shape they were going to come out of the ground. And sequencing wise, we've already done. Political muscle and they can change, they can have things their way, right? You know, throw attention. So we moved the building, and that's why the pole day working on. That's why the pole is so damn close, because we didn't think it was that close until we were done. And then the trade-off of that was they got to break their own rules. So we all know working here about the 100-foot CBA buffer, right? We got 50-foot sea versus 50-foot landward. CBF self-imposes a 200-foot CBPA buffer. And we are infringing upon that by 7 feet, if I remember correctly. If the corner of the deck is ever so slightly past, and that was fighting a 20-foot, half-inch building-to-building separation, so we didn't have to have fire rate protection. There was only one answer. The nice thing about it was when this problem came up, there was only one answer. Like, you can't go that way, you can't go that way, you can't go that way. Okay, here's where it goes. And luckily, it looks like it's going to more or less work out. So, standing here, I can't see that building at all.
It actually worked out.
And for the most part, in that building, you really can't see this building at all. Not very much of it, at least. And what it kept us out of the capital, an awful lot of debt just serving the deck for 2 days. 2 decks equivalent to the end of the day being ridiculous. So it just helped us be a little bit more efficient at the end of the day. And I think that's a positive thing, but Tanner was on the fault. So Tanner really sucks, especially in his life. That's why Dave's taking so many pictures. Anybody who's playing with sustainable or high-performance buildings knows that you really try to limit where your openings are, which way they face, and how you protect them. And we kept telling Chris, we're only going to the south, we're only going to the south, we're only going to the south. And I think Todd opened his big fat mouth and said, what if we rode the corner and we looked that way a little bit too? That's a good, it was the right call at the end of the day, but we have this weird roof that sort of wraps around the building, and then got the cantilevers out on one side, trying to get some protection from the eastern sun, which is more like the top of the protection of what else we're in. But in a lot of other regards, we really got to sort of copy their playbook. Not that it's a super unique playbook when it comes to high performance buildings. You deeply shade your southern overhangs. You take as much of you milk your northern openings to all they've got, and you really, really cut down on eastern and western overhangs, or excuse me, openings. So you know, it's building section wise, using a lot of their tricks. So these are the big sliding doors that exist. And so the idea is that the classroom is not just this room, but also out to the extent of the deck. It should be really, really nice when it's all said and done. So we didn't show you guys the floor plan, but not the much one. All of this is to support one classroom, one office, and 2 toilets. We've got a mezzanine up above that they'll use for overflow classroom space. We have stuffed our mechanical units in a space only hobbits will love. It's 5.5 feet tall to the uppermost point in that space. It's probably 5'2" clear at the low end of that space. It's crazy shit.
Before everybody got there, we talked about the team service program.
Chris, yeah?
Chris, and so there's going to be a morning and an afternoon session, correct? Is it 50 per session or is it 25%?
It's, if I get this right, Chris, it's 25, it's a 2-year program, juniors and seniors. So juniors will be 25 morning, 25 afternoon in the space, As a senior, you're doing what amounts to an independent research project, and you are assigned here, 25 kids in the morning, 25 kids in the afternoon, but they probably really won't be here. They'll be doing their independent research, they'll be out in the field, they'll be in a library, they'll be working from home. They'll come in and talk to the professor or the teacher, and they'll have like a one-on-one meeting or a one-on-3 meeting or whatever. So yes, it is supposed to support 100. It may not be that in the first year because there won't be kids that are in the second year, are there?
Correct. The first set of juniors just started virtually learning a couple weeks ago. That's a month ago now. And so that's exactly right, Michael. So they'll finish. So they're learning about sustainability. They're formulating what their area of expertise is going to be. And then at the end of this, they're working on their senior project and their internship. As Michael said, they'll be out in the community and then just provide kind of a target that break up the spaces, multiple spaces that the students can come and work independently while they're just doing the work. So it's only 25 kids at a time.
Yeah, that's why it's a very generic 1,000 square foot classroom like you would have in pretty much any school building in the country. It's not, I mean, this is space, it's not very big. And just the rectangle is not very fancy. So the deck will be cool, very similar to the deck next door, with the big sliding doors, over there. We have a swinging one over there because of egress. Behind this wall, we can't see the wall of the deck. There'll be a big stainless steel sink, or again, more of that, like washing things that are coming out from outside, or coming in from outside. Where we stopped having openings, we strengthened the roof architecturally to not get an inbuilt, not solid. Trying to give the students like an armature that they can play with, so they erect their own shading devices to study what shading fins set like this do, or they, attach webcams or any kind of sensors or whatever. We're trying to give them, Chris sort of alluded to it earlier, that the building will be a laboratory. We're trying to make the building part of that laboratory. So there's just some tube seals hanging out there, hoping for someone to come and hang them somewhere, add something to it. Interesting to watch happen. Linoleum, which sounds very 1970s to us, except it's bio-based and it's pervious to water. So because it's exposed concrete down below, we are standing where we'll have a vapor barrier that will tie into the outside vapor barrier, 6 inches of insulation, a self-leveling compound, and then linoleum floor like we use in schools for a long time. Nothing really crazy. But again, we tried to make sure that all of our material choices were as bio, local, bulletproof, whatever we can get. Not have to do them twice is the most sustainable thing we can do. But we want things that last a long time and could be used. CBF has a big track record with linoleum floors and other buildings, and I've seen how that stands up to being used, and we're comfortable with that.
In Bronson, there's opportunities to reclaim floors, reclaim gym floors, things like that, which is great. We learned over the last 5 years that every project is treated for something. You have to be moving that stuff. You have to be really careful. But that's a lot you can kind of get into. So, and bring a lot of products that bring much clearer in, something that's not working all up. Plastic all over. First AIA Hampton Roads Heart Hat Tour that we've tried since March in person. So we really appreciate the design team and the owner allowing us to do this. We are going to enforce, some COVID-19 situations, so everyone will be asked to wear your mask, especially when we're inside, and just keep your distance. I'm not passing around the sign-in sheet. I'm checking you off, so I think I've got everybody who's here so far, and I'll catch whoever else comes up. Our tour this afternoon is sponsored by Pella, whose windows were used and doors were used on the project. So we're going to give them a few minutes at the start here to tell us how it was used and why, and that kind of thing.
So we're up. Hi guys, I'll try to make it brief. My name is Elizabeth Connolly, and I stood over here and take this off. Did you guys feel comfortable with that? Okay. Anyway, I'm the art rep for Pella Windows and Doors, and we're really happy to be here. I was telling Steve when we were walking up that I came here for, I don't know if anybody was at the AIA Awards.
I was.
That was your last.
We talked.
I remember.
Yeah.
I remember. And I just, because I'm not from this area, and I remember coming up through Shore Drive and then all the residential neighborhood, and then there was this like gem that was just kind of tucked away, and just walking up and seeing the building that fits so nicely in the entire landscape. I just love it. So when I found out that we were collaborating with them on contracts, I was very excited about the project. So I think it might fall to try to say something that is not what I should be saying, because jump in and correct me, but I think one of the reasons that Michael went in the direction of Pella Windows and Doors was the particular window that was selected, number one. It's our architect reserve traditional window, and Pella has been in business for almost 100 years. This is a pretty new product for us. It's been on the market for 2 years or so, I would say. It's a good clad product. It's historically accurate. It's very clean. I think it probably met your design aesthetic. So that's the one thing. And that, as everybody knows, this building is extremely energy efficient. So we were able to bring to the table some, options that got to numbers that were very attractive in terms of the building's overall footprint. So the first thing that we did was and like most of you are probably familiar with low E glass. That's what we this is an extra layer that is applied, and it prevents UV ultraviolet light rays from getting into the space. both were dramatically decreased. And I looked at our APM and I saw that the numbers for the U factor with the triple pane it was 19, with the dual pane it was 26, it was 28 for the solar heating coefficient, 17 or something. So that was a pretty dramatic change. And I think those were we were able to meet the design criteria and also the performance criteria, which is why I think they chose Pella, I think so. So I don't know if you have anything to add to that.
Well, I mean, we didn't do this original building, but ultra high performance windows, not storefront systems, which we all know they have their own challenges, have made absolute leaps and bounds in the 5 years or so that since this building opened. These windows are some crazy Swiss German thing, right? So it was really hard to get, and they were really painful, and Chris hates them. Now we can get American-made stuff that meets all performance criteria that we need. So aesthetics was in there, but this was absolutely a performance-driven building. And Pella was able, through all of the things that Elizabeth mentioned, meet some pretty aggressive performance criteria that we had. And again, it was the U factor, the solar heat gain, all the things that the glass could do, but then also the sort of inherent properties of a wood-clad, where there's some R value in there that isn't in like straight metal windows. We were happy, and obviously it's a good product. It seals well. We're able to meet the air leakage targets and things like that. So, I mean, it was, I would say, 90% performance driven. We were able to get the numbers we needed out of. It always has to fit a budget. Even Chesapeake Bay Foundation has limits to the amount of dollars they have. So it's been good. And are they in yet? I know they were showing up.